There we have it. That's the taste portion. Pause. All right, for the remainder of the lab, we're going to be testing the properties of these four substances based on what they do with various metals, carbonates, and then organic compounds. So the first is the reaction with magnesium. You've seen it several times. So if we zoom in, we can see the reaction rate of A, B, C, and D. And it's fairly obvious. A maybe very slowly, but I think that's just bubbles in the water. B is reacting fairly quickly, C violently, and D, again, I think those are just bubbles collecting from the water. So A and D not, and B rapidly, but C violently. Pause. Still under the reaction of metals, now we're going to react zinc with the different substances. If you remember from the periodic table, zinc is less reactive than magnesium. So we put zinc in A, B, C, and D. And again, we see C is reacting quickly, B slowly, and A and D are sitting there like so much lumps of zinc. All right, pause. Okay, the next is part D, the effects on carbonates. And carbonates is just a type for any number of different minerals that react with acids or bases. And I don't want to give away which it is, but you should know from the notes. Okay, so here we will see the four substances. Reaction with A, B, C, and D. And once again, oh, I don't see any in, nothing in B. Lights are on, but nobody's home. We see C is reacting vigorously, and B well, yeah, there's small bubbles on B.
Maybe more solvent.
More? There we go. All right. So I just recognized that I forgot to do part B, which is the touch test. So these substances are known to feel a certain way to the touch. So I just take a small drop and rub it between my fingers, and it is somewhat slimy, slippery. And then rinse in between. Then solution B. Just watery. See? Ah! Just kidding. Although I do have a cut, and I didn't realize it until just now. But it feels watery, but it does sting. Then solution D. Ooh, very slippery. Very slippery. And since I know what it is and the concentration of it, I want to get it off my hands. Pause. Okay, so we're going to skip section E, the effects on organic substances, and go right to section F. Section E takes a while for it to have its effects, so we're going to do that last. So first is red litmus, and here we have red litmus turning blue in substance A, staying red in substance B. Ooh, dark red in substance C, and blue in substance D. Pause. Okay, and then for blue litmus, blue in substance A, red in substance B, darker red in substance C, and darker blue in substance D. And now for methyl orange. A few drops in A, B, C, D. And methyl orange is an indicator that changes with, it's red in acids, kind of an orange in a weak base, and a yellow in a strong base. And now for bromethymol blue. And bromethymol blue is blue in base and kind of yellow or green in acid. Okay, I misspoke. The bromethymol blue is yellow or orange in an acid. Okay, pH paper. There's substance A. Looks like it's about an 8.5. And you can put pale green. Substance B. Looks like about a 2.5. And you can put orangish red. Substance C is a dark red. Looks about like a 1. And substance D, is about 14. And it's a dark midnight blue.
Bit overexposed,
Pause. So now we're going to do section G, effects on each other, and we're going to add 5 drops of C to the spot plate, and then a drop of universal indicator. Pause. And then we're supposed to add 5, or drop by drop, D to C, and note the effects. There's the 3rd drop. Fourth drop. Fifth drop. 6th drop. Seventh drop. Oh, I think I went one too far. You notice there was a half drop, and so I think if I had one less drop, we'd be right about there. Let's try just a tiny drop of C. It's going to be hard to get it neutral. But you can see somewhere in there, and we can't go half drops at a time. But now we're back to a weak acid. So we went from an acid, passed to a base, and then back in here, drop for drop. Pause. All right, so now we're supposed to do the same thing with A and B. Take 5 drops, 1, 2, 3, 4, 5 drops of A, and then a drop of universal indicator. And if you notice the pH range, and then drop by drop, add B, 1. Whoa. Two. Okay. And we can see that we're almost neutral. Let's go one more drop. 3. Is that 7? Okay, so evidently B is a little bit stronger than A. But they've neutralized each other. And A and B neutralized each other. Okay, so here we are, section E, the effect of on organic substances. Here's a piece of carrot that's been sitting in A, and it's still intact. B, still largely intact. C, mostly intact, although I was able to break it in half. And then D is pretty much mush. I picked it up and just squeezed it, and then it broke into pieces. Then we go to the protein, and this was just a piece of turkey meat. And you can see in A, it's starting to decompose a little bit. B, largely intact. C, largely intact, maybe a little decomposition. And D, you can see is pretty much mush. And then for fat, this was some refrigerated butter. And you can see A, largely unchanged, as is B, as is C, but D, it was easy to break apart, starting to decompose. Okay. That's it for the various properties of acids and bases. Hopefully you got the data as we went through. Remember, you can rewind. Not even rewinding, just go back. You can pause. You should be getting the data in the data table as you go along. Hope you're having fun. Stay safe and strong.